Hi everyone, myself Gksr. I'm from EC department from Sri Venkateswara College of Engineering, Bangalore. Today I'm going to discuss about the topic the operation of MOS transistor in accumulation, depletion and inversion mode and the steps involved in MOS fabrication. This is the topic that gonna discuss by me today. Operation of MOS transistor in accumulation, depletion and inversion mode. Most metal oxide semiconductor transistors are fundamental components of modern integrated circuits commonly used in digital logical gates and analog amplifiers. They operate in three different modes: accumulation, depletion, and inversion, depending on the voltage applied to the gate terminal and the resulting charge distribution within the transistor. Most transistors in accumulation, depletion, and inversion mode, the pictures are given in the slide. Uh, accumulation mode. In accumulation mode, the voltage applied to the gate terminal is such uh, that it attracts free electrons from the semiconductor substrate towards the surface beneath the gate oxide layer. This creates a layer of excess electrons or an electron communication layer just below the gate oxide. The presence of this electron accumulation layer forms a conductive channel between the source and drain terminals of most transistors, allowing current to flow from the source to drain. In this mode, the most transistor is on and is conducts current easily. It typically operates with a positive gate voltage VGS. Depletion mode. In depletion mode, the voltage applied to the gate terminal is negative but not strong enough to invert the channel. Instead, it creates a small region of depleted charge carriers beneath the gate voltage. Charge carriers are both mm, electrons and holes. The depletion region uh, reduces the conductivity of the channel, making it less conductive compared to accumulation mode. Depletion mode. Metal oxide semiconductor transistors are not commonly used in digital applications but can be found in some analog circuit designs. They operate with a negative gate source, negative gate voltage source, VGS. This is about the depletion mode in the MOS transistors. Coming to the inversion mode, in inversion mode, the voltage applied to the gate terminal is sufficiently negative to attract charge carriers, electron for N-type and holes for P-type. P-channel MOS transistors are created an inversion layer just beneath the gate oxide. The inversion layer forms a conductive channel between the source and drain terminals, establishing a high flow of current. Inversion mode and MOS transistor are the most common type used in digital logical circuits. They operate with a negative gate voltage, VGS for N channel. Most transistors and positive VGS for P channel MOS transistor. This is about the inversion mode in most transistors. Moving to the next slide. That the steps involved in NMOS fabrication. The fabrication of NMOS, N-channel metal oxide semiconductor transistor, is a complex process that involves multiple steps in semiconductor manufacturing. Here, I will outline the key steps involved in fabrication of NMOS transistors. Substrate preparation. The process begins with silicon water, which serves as a substrate. The water is typically made of single crystal silicon and is highly polished to provide a clean and flat surface. This is the fabrication process of NMOS device, uh, where we can see the stepwise process of fabrication of NMOS device. to the next process, thermal oxidation. It is nothing but field oxide, a thin layer of silicon dioxide as CO2, known as field oxide, is growth on the silicon water surface. The oxide layer insults region where transistors will be built and defines the active areas. Photolithography. Photolithography involves applying a layer of photorest method material into the water surface. A mask is used to uh, project a pattern onto the photorest. The pattern defines the locations of various transistors components, including the NMOS transistor. Exposure and development. The wafer is exposed to ultraviolet UV light through the mask. The area exposed to light become more less soluble depending on the type of photorist used. After exposure, a developer solution is applied to remove the soluble portions of the photorist, leaving behind the desired pattern. Etching, ion implementation, thermal handling are the next steps of the fabrication of NMOS transistors. Gate oxide growth, lithography, and etching. It is nothing but gate fermentation, source and drain formation um, are the following steps for fabrication of NMOS transistor, N-type metal oxide semiconductor transistors. Interconnect and metal layers. We can see we previously saw an pic of the steps involved in the fabrication of NMOS transistors. These are the final steps for fabrication of the NMOS transistors, that interconnection of the metal layers, passivation and testing. Uh, Thank you everyone.